Good morning, children. Welcome back to chemistry class. Now we are in lesson 6, metals and non-metals. And this is our video session 15. This is a part 2 of this lesson. Recapitulation. In our last video session, we studied metals, non-metals, melting point, boiling point, conductors, sonorous, and density. Our next topic is metalloids. What are metalloids? Metalloids, physical properties more like those of metals, but chemical reactivity is more like that of non-metals. Many atomic properties are intermediate between those of metals and non-metals. Actually, these are not a metals or non-metal. They are in between. They are intermediate between a metal and non-metal. Some of the reactions it can show as a metal features, and some of the reactions it may be act as a non-metals. So we can call it as a metallides because sometimes it has been acting as a metal, other times it is acting as a non-metal. So it is showing a properties in between a metal and non-metal. That's why we are calling metalloids. These metalloids are also called semi-metals. They are having properties intermediate between those metals and non-metals. Examples for these non-metal: boron, silicon, germanium, arsenic, antimony, and tellurium or metallides. So these are having a properties in between a metal and non-metal. So what are the properties of these metalloids? Metalloids are hard solids. So it is a one among a property of metal. So it is in this place it is acting as a metal. They may or may not have luster. Some metalloids they have a lustrous appearance. Lustrous means already we discussed in the metals properties shiny appearance. So some they can have a shiny appearance, some they cannot. Example: germanium, antimony, and tellurium. So they have a lustrous appearance in their structure. And the next property of metalloids is metalloids have densities intermediate between those of metals and non-metals. Yes, the densities of these metalloids also acting in between metals and non-metal. The conduction of heat also intermediate between metals and non-metals. Yes, because it has been placed in the periodic table in between metals and non-metal. So obviously it shows the features also like a metal or non-metal. Here they are saying about a conduction of heat. So what they said, except some metalloids being good conductors of electricity. So they are rather conduct or nor. So some of the metalloids they can conduct heat as well as some of them are conducting electricity. Those are arsenic and antimony not conduct electricity. So in that also these two metalloids they cannot conduct electricity, but silicon and germanium are semiconductors. Semiconductors means they can conduct electricity sometimes, sometimes they won't conduct. So semi means off. So they are silicon and germanium. We can call it as a semiconductors. Here we have some of the metallites how it is looking. Here silicon see it is shiny in appearance, so it is showing a property of lustrous. Boron, so boron is dull in nature, so it is not it shows the features of non-metals. Antimony and germanium, these two also very shiny in appearance, lustrous appearance. Arsenic also while looking it is very shiny in nature. antimony and tellurium. These two are very dull appearance, so it seems like a non-metal. Metalloids like silicon and germanium are semiconductors. The semiconducting property of these elements has made them highly useful in the electronic industry. Yes, it is a metalloid. It can conduct electricity also. So how they are conducting electricity? So when the time of conduction, one side is acting as a positive, another one is acting as a negative. Then we are getting an electric charge from this semiconductors. So that only the electronic industries, they are using the silicon and germanium to generate electricity to do their industry work. For example, the chips used in the TV. In the TV, we have a small chips, and then computers, phone are used to made of silicon. Yes, so the electronic devices, the chips and all made by this silicon. We are now in the topic alloys. What is mean by alloys? When the two or more metals mixing together to give a new metal, that one we can call it as a alloys. A solid solution, that is homogeneous mixture of a metal with other metals or non-metals. Either it may be a metal or non-metal also is called an alloy. So when the metal is mixed with another metal or also metal non-metal, we can get a new solid structure. That is structure we can call it as a alloy. Here we have an example of alloys. The first one is steel is an alloy of iron, manganese and carbon. Yes, the steel itself we have a iron, manganese and carbon. Regularly we are using stainless steel vessels at your home. Likewise, it has a mixture of iron, manganese and carbon. Next, brass. Brass is an alloy of copper and zinc. When the copper is a reddish brown metal and zinc is a white metal. When these two are mixing, we are getting a yellowish color brass metal. So, when mixing it two or more metals and non-metals into it, we are getting another solid structure of metal. Here we are going to see the properties of alloys. An alloy is usefully older and stronger than the parent metal, and at the same time it resists corrosion. So why we are doing the alloying? So when the time of alloying, it is very strong and hard, we cannot break it easily, as well as it is resist corrosion. See, for example, iron. Iron, when it catches moisture, it can be rusting. But in the case of stainless steel, regularly using the vessels at a home, it won't get any corrosion. So easily it will not get corrosion. Next, properties of alloys. The first one alloy is bronze. In that we have a 90 percentage of copper, 10 percentage of zinc. So what is the property? Hard and strong, doesn't corrode easily, has shiny surface. Yes, very hard, and then it won't corrode, then shiny surface. So what are the uses of this? To build statue and monuments. So many of the statues and monuments was built by this bronze. In the making of medals, swords and artistic material. So the making of medals, you have a bronze medal, then swords, as well as the artistic material. Next, brass. In the brass we have a 70 percentage copper and then 30 percentage zinc. It is harder than copper. So it is the main parent metal is copper, but it is very hard when we compare to the copper. So uses of this in the making of musical instrument and kitchenware. So the brass is used for making a musical instrument as well as a kitchenware. Next, steel. So 99% of iron and 1% of carbon. Here iron is a metal, carbon is a non-metal. Properties odd and strong. In the construction of building and bridge, so we are using a rods, steel rods. So in that steel rods was made by iron and carbon mixture. In the building of the body of the cars and railway tracks. So body building of the cars as well as the railway tracks also this steel is used. So how strong it is you can know that. Next, stainless steel. This is a mixture of 70% of iron, 8% of carbon and 18% of chromium. So what is the property? Shining, strong, doesn't rust, yes. And then to make a cutlery and surgical instrument. So cutlery means for cutting knives we are using at a home, and then surgery. So for surgical instrument in the hospitals we are using this because it doesn't rust, always it doesn't rust, so they are making the surgical instrument of the stainless steel. Dura-aluminum. So dura-aluminum is at 93% aluminum, 3% copper, at 3% magnesium and 1% manganese. So in that it is very light, right, and then strong. So what is the uses? To make the body of the aeroplanes and bullet trains. So to make this useful for the making of aeroplane body as well as a bullet trains. Next we have a alloy powder. It is made by 96% tin, 3% copper and 1% antimony. It is lustrous, shiny and strong. In the making of souvenirs it is used. Here we have other examples of alloys. Gold alloys. A pure gold is a soft and is therefore not suitable for making jewelry. Because very soft, soft means what? It can be easily breakable. So it is made harder and stronger by alloying it with silver, copper or both. So what they are doing? They are mixing this gold with the silver or copper. Because of what? To give a hard structure to the gold. The alloy is still malleable. Malleable means what? We can spread into thin wires. So to give a hard structure of the gold as well as and then to give a malleable. So we have to make a watering wire so that we are adding silver and copper to the gold. Next, amalgams. What is an amalgam? Alloy of mercury are called amalgam. So when the alloy, when mercury is mixed with other metal, we can call it as the alloy. Silver and tin amalgams have many laboratory and industrial uses. So here silver and tin mixed with mercury, it is used for the many laboratories as well as industrials. Here is the assignment for this class. Write the properties of metalloids. What is an alloy? Write some semiconductors name. What are metalloids? What are amalgams? Thank you, children. Have a wonderful day.